All right, when we get our Juniper box fresh from the factory, we're going to need to rack it and stack it and get connected somehow. So it doesn't matter if it's Cisco, if it's Juniper. Really, that means serial connectivity. Laptop, no modem cable, somehow getting connected to that box. So let's imagine that we have our device here, some let's say MX router maybe. We can't Telnet in, we can't SSH in. Those services are not enabled. There's no IP address configured. Really, the only choice we've got at this point is to connect to the routing engine's embedded serial console. In fact, we have two choices. So we have the CON, so just the console, or an aux port, as you can imagine, or auxiliary port. It does not matter which one you use. It equally either could be used to connect to the device. Our null modem cable, RS-232, going to a RJ45 jack, can be plugged in here. So let's say we've got some laptops sat down here. USB these days, I guess, connected to our RS-232 serial converter. Bring up our terminal emulator and hit enter. We're going to see ourselves able to log in. We still need to log in. We still need a username, I should say. If it's fresh from the factory default config, there will always be a root user. So ROOT root, basically God on the box, can do anything, all privileges. And factory default configuration is no password configured for that root user. Once we're able to log into the box and configure an IP address, get it connected to something. Let's say we configure this FXP0 interface here, the management Ethernet interface. Maybe that's connected to some out-of-band management network if we're really lucky. We've got some engineering jump-off server over here. Now we're actually going to be able to Telnet, SSH, FTP, maybe even TFTP or something, from this server over to our box. So all of those services are possible if they're enabled. By default, none of them are turned on. So when we've configured that console, that serial connectivity to the box, an IP address plus enabling SSH as a best practice is probably the first thing we've done. So as I mentioned, it could be SSH, it could be FTP. In fact, for file transfer, probably we should prefer SCP, or secure copy over an SSH session. We could have Telnet, HTTP. We've got web GUI management on the box if we want, or I should say really, we can choose between HTTP and HTTPS if we want to be more secure. But all of that is only possible because we configured an IP address and enabled these services on the device. And in this case, we're talking about connecting to the FXP0 management Ethernet interface. That's embedded in the routing engine. So we said this was our RE here, the brains of the box. Before any line card boots, before any of the gigabit Ethernet or ATM or serial or whatever else interfaces you got in the box come online, the RE will have booted and this FXP0 will have come up. So even if every line card is removed, we could still get some management in and out via FXP0. It's probably worth noting at this point that you cannot route traffic via FXP0. We cannot receive traffic in on FXP0 and forward it out on some other line card, or in on a line card and out on FXP0. This management is purely, this interface, is purely for management purposes. So what else should we say? Well, I guess at some point, we want to actually configure some of the line cards in the system. So maybe down here we've got a couple of different line cards. And maybe one of these ports here is, I don't know, gigabit Ethernet 0, 1, 2, 3. So line card 3, pick 3 down at the bottom there maybe. And this is port 0. Now we could configure an IP address on this interface and similarly SSH, FTP, Telnet, TFTP, netconf programmatic configuration over SSH. Take your pick, whatever we've enabled, but only because we've actually taken the time to enable them. So in iOS, you're probably used to making line VTY configs and so on. Quite a bit simpler in Junos. So we'll look at some config examples in a moment, but you're just going to go underneath the system hierarchy and enable the service you want. You might simply just say set system services SSH and commit. You can do a whole load of more fancy stuff. Limit the number of connections. How many rapid attempts to connect can we get before we're going to force a kind of hold down time on more connections. In iOS, you might be used to associating ACLs with some of that line VTY configuration. In Junos, that's not how it's done. We're going to talk later about input firewall filter against the loopback interface on a Juniper device. That is a kind of unified place to limit all types of access to the management plane and protocol control plane of the box. So that is possible, but for now, just turning on these services, we're going to leave it open for anybody who can connect IP-wise over a production interface, so down here through production, or some jump off from engineering through an out-of-band network over to our device. All right, when we get our Juniper.
Here we have a couple of examples of logging into the box. So at the top of the picture here, you can see, we've got a box that's already configured, host name set, some quality user already created. And, when we log in, we get what we expect: username, password, and, we arrive at our operational mode prompt. So username @router, and then our greater than symbol. It might be worth noting that just above the username, you can see the TTY, the terminal we've logged in on. And in this particular box, TTY U0, that would be a serial console port on some models of Juniper device. Below that, we've got an example of more or less the same things, but this time it's a root user logging in. Now, if it was fresh from the factory, we wouldn't need a password because no root password would be set. But here we're prompted for a password. We give it, and then we get something a little bit unusual. You can see that instead of immediately coming to the Junos CLI, our prompt now reads root @hostname or router, and then this percentage symbol. And that's because we've been dumped into the Unix shell underneath the Junos CLI. So this is kind of a little backdoor. If we had some problem with the CLI code on the device, we know that with the root user, we can always end up coming direct to the Unix shell first. Anyway, we don't really want to do anything here. We've no real need to CD around the file system or ls-l list the directory listing or something. So we're just going to type CLI and immediately start that Juniper standard CLI.
So maybe before looking live at the CLI, it's good just to talk through some of the main differences between navigating from operational mode into what Junos calls configuration mode, and compare that to what we know already from iOS. So you can imagine we have some Junos host, we want to log into, we're going to SSH, telnet, and as soon as we give username, password, prompt responses, we expect to find ourselves logged in at our username at some hostname prompt. And maybe the important bit here is that at the end of that prompt, we're going to see this greater than symbol. In Junos, that definitely means that we're in operational mode. iOS, we're thinking maybe, okay, I need to type enable, I need to escalate my privilege level. But in Junos, that greater than prompt is simply telling us, okay, you're in op mode. In iOS, like I said, we might be going to enable next, increase our privilege level, allow us to do more on the command line. In Junos, what exactly user X can do with this operational prompt is determined by the user's class. So we're going to look at that later, but for now, let's just imagine every user we've configured has a class and is automatically inheriting the privileges, the rights that class has associated with it. Okay, so we could run a bunch of operational mode commands now. We could show the version, show the active config, show the status of interfaces. But let's imagine the next thing we do is go from operational mode into config mode. Now, we can achieve that in one of three ways. We could just simply type configure. If we type configure, we're going to be creating a candidate configuration, something that's not currently the config of the box. We can change in, however we wish, change with hundreds of add, delete, set commands, whatever we want. And when we're ready, we choose to commit that configuration. But, maybe a problem with that is that if another user and another user log into the box at the same time, and each of them type configure, they're going to be sharing that single candidate config file. So just to review, we have three options. We said this standard configure, shared candidate mode, if you like, and then maybe our best practice that I think we should all be, trying to ingrain as a habit for ourselves. We're going to prefer to type configure space private, and that's going to take us into config mode. But each user is now going to get their own private candidate file, change it in any way they wish without affecting the current running configuration. And at the moment they're ready, they're going to commit. And they're only going to commit the changes they've made to their private candidate file. So this 99% of the time is how we want to enter configuration mode in Junos. Another last option that we can look at later in the CLI is configure exclusive. The name's a bit of a giveaway. You can well imagine that if we configure exclusive, we're going to create a candidate that we can edit, and it won't go into effect. Whatever changes we place there will not be the active running config until we type commit. But we're going to be holding, as that user, an exclusive lock on the box, or an exclusive lock on the configuration of the box. If another user logs in, tries to edit the configuration, they're going to get an error message telling them that the config database is locked. And, well, the only way to fix that would be either for me to finish and log out, or for another user with privilege from operational mode to request that I'm logged off, kill my session effectively and release that exclusive lock. Anyway, we've, let's say, done this configure private, our best practice. And we now hope to see that the prompt has changed. We're still going to see user at hostname of the router. But now we hope that at the end of the prompt, we see this hash mark. This is telling us, reminding us, oh, we're in config mode. And above our prompt where we're typing, we're going to have a banner in these squared brackets. Okay, the banner will begin by simply saying edit, reminding you again in configuration mode that you can edit the candidate, but also telling you that you're at the top. If you're at the top of that candidate configuration, then it just simply says edit. Maybe the next thing we do is enter at this configuration mode prompt something like edit interface X, here GE123. And when we hit enter, we're going to see that the prompt above our banner is refreshed and changed. Okay, so now it's reminding me I'm still in edit mode. I'm still changing my candidate config. But this time it's telling me precisely which interface I'm in. Now, if this was iOS, we would know we were in config mode. We'd be seeing something like host name, config. Oops. And if I typed in some interface name here, that might transition to tell me that I'm config for an interface at the same host. But it kind of leads me to guess where I am. I know I'm configuring an interface, or it reminds me if I'm configuring a line or a routing protocol, but not, which line or which routing protocol or which interface. So some similarities, but, Junos is being a bit more helpful here for us. You can imagine now underneath that particular part of the candidate configuration, we can set something, delete something, make whatever changes we wish, still not affecting the active running configuration. And when we're ready, we're going to type commit, and that'll push that candidate into the active running config at that moment. Also here we see that, maybe we have more to do. Maybe we're going to configure that one interface, and we want to go back to the top of the configuration tree. In iOS, you end up typing exit, exit, exit to jump back up your kind of configuration hierarchy. In Junos, we make life a little bit simpler. You could type exit, but probably better to type top, jump immediately from this position, back up to the banner telling us, okay, you're at the top of the configuration tree, just simply telling us edit in the banner, and we're ready to carry on with our configuration. Let's have a look at some examples. So probably one of the first things that engineers new to Junos notice when they're coming from the Cisco world is that in configuration mode, things are a little bit different. In iOS, it's very true that whenever we make changes in live production, we need to be careful, particularly because every single command enacted in iOS takes instantaneous effect. You go in conft, you set an IP address, it instantly bang appears on the interface. You shut the interface down, it's gone. Every command that is syntactically correct, the minute you hit enter, it's entering production. And that means that with iOS, it's not just important to think about what you're going to do during a maintenance window. or configuration of the live network, but particularly in what order you're going to do it. Shutting an interface down before having brought an alternative path up could be disastrous. You could end up cutting yourself off from the box. So like I said, the thing we notice when we go to Junos for the first time from that environment is config mode is very different. We could maybe describe it as a batch configuration mode. What do I mean by that? I mean that in Junos, when you type configuration, what you're really doing at that moment is triggering a copy of the current active running config. So we can imagine here, inside our box or MX router or whatever it is, we have lots of different configuration. And the moment we type configure, we're literally taking a copy of that current active configuration and making a copy of it. So we've taken the active config and made it a candidate configuration. This is a text file held within memory on the box, well, in fact on disk on the box. And in config mode, you're effectively editing that candidate configuration. I mean, obviously the CLI is enforcing syntax, making sure all the commands you give are valid commands and so on. But the important point is, as we make changes, let's say we've got a user A SSH down in here in the box. User A SSH is in, types configure, goes into configuration mode, and then makes some changes. Maybe user A does something very simple. Maybe they change the host name of the box. Maybe they add a new user. If they type commit, all of that configuration is going to be checked, or sanity checked, I should say, for some basic kind of conflicting configuration statements that are not allowed from Junos' point of view. And then if that check is good, then what was the candidate configuration will become the active configuration. All right, so this sounds great. I mean, now we don't need to worry so much about what order we do things in. We might make 1 change, 2, 3 changes. We know that as we make changes on the CLI, all we're actually doing is editing a candidate configuration that has no effect on the current production behavior of the device. Like I said, once we type commit, it becomes active. We don't need to worry about the order and so on. What else was I trying to say? Oh, I remember now. I'm imagining a bad situation that's happened to me more than once. This is a nice story, but what about if we imagine another user? Let's say we've got user B down here. Comes along. User B, SSH, connect to the box. At the same time that user A is still in configuration mode, editing that candidate. And now he goes into config mode as well, types configure. He's going to see a warning on screen. It will tell him warning that another user is currently with, or the candidate configuration is currently being edited. But, maybe user B is busy, distracted, doesn't read that warning on screen, and starts entering his own commands. So now we have one candidate file with 2 or potentially even more users logged into the box. They've been warned, but maybe they didn't see it, and they're now adding to that same candidate. Let's say that user B types commit when user A is still in the middle of his changes. What's going to happen? If we're lucky, user A is doing something that is only partially configured within the candidate. Maybe he's creating a new BGP peer and it doesn't have the minimum mandatory statements. So when user B types commit, we get an error. The commit fails, and this kind of is a wake-up call to user B. Hey, this is weird. Somebody else is adding to the same candidate as you. If we're unlucky, it passes the minimum sanity check, and we get some partially finished config by user A alongside B's changes all at the same moment, pushed to active. That could be disastrous. So for this reason, we actually don't prefer that users, when logging into the box, enter configuration mode with just the straight configure command. We'd rather they use configure private. So it's probably fair to say you should think of that as a best practice. All right, so we already talked about the idea that just entering config mode with the configuration command on its own can have some potential issues. We said that maybe we've got 2 users both editing the same candidate. That could potentially result in some headaches for us. We said that far better, best practice is to do configure private. So let's see exactly how config private would save us from the situation of 2 users kind of fighting or conflicting with each other. Let's imagine this, let's say user B down here. User B logs in, types configure private, and we've gone into config mode, so we expect that spawns a candidate configuration. All the changes that user B makes are just simply editing that candidate and having no effect on production until he's ready, until he commits, until our commit check passes, and this becomes the new active configuration. So user B is merrily typing away. Everything is good. And now we imagine that user A logs in at the same time. So user A makes a connection, types configure private, and this spawns a separate private, hence the name, candidate configuration file. All of user A's changes are contained within that particular candidate, and at some point one of them is going to commit first. It doesn't matter who commits first. Let's say that user A commits first. We can imagine if the commit checks pass, then all of his changes from his private candidate are now merged into the active running configuration. Later, could be 2 minutes later, it could be half an hour later, it really doesn't matter. User B is going to come along and run a commit, hopefully pass his commit checks, and have all of his changes merged alongside the user A changes in the same active running configuration. The system handles intelligently for you this merge. What do we need to worry about? Some things we can't fix. If user A changed the host name of this box to foo and typed commit, and user B makes 20 changes in his candidate, but one of those changes is to change the host name to bar or something else, well, when we commit, 19 of his changes get merged in alongside with no effect to what user A has achieved, but that one command that's directly conflicting, user A setting one host name, user B setting another host name, obviously whoever committed last at that moment is going to win. That we can't fix. At some point we need to coordinate the human members of our team, make sure they're not fighting each other on the box. But I think you'll agree this is a lot nicer situation than just hoping the 2 or however many users in our ops team notice a warning if they simply type configure, if they don't use this configure private. There is one very small downside to using configure private. It's really just a minor annoyance. Once you've done configure private as opposed to just configure to change the mode of operation on the box, you can't commit unless you're at the top of the configuration. So if you've jumped around in the config tree, you're buried under OSPF or BGP neighbor config, type commit, you're going to get an irritating warning that tells you, warning, you can't commit in private mode unless you're at the top of the configuration tree. Once it becomes habit, no problem, but first few times it's slightly annoying. Right, cool.